All right, so we are looking at summation notation. So summation notation is a shorthand notation for denoting a series when the general term of the sequence is known. This little symbol here is called sigma, and it's used, it looks like an E, and it's used in mathematics to say you're finding the sum of a set of numbers. The numbers to be summed will be on the right side of the sigma symbol there. So the notation, summation of x of I, tells us to find the sum of all of the x values. The notation, the summation of x plus 2, means we will add 2 to each data value before finding the sum. And the notation of the summation of I equals 1 to 6 to I shows that I is the index of the summation from 1 to 6. And we will multiply each of those numbers and then sum them up. We'll multiply by 2, but we're only going to use those numbers right there. If we have just the x, we'll have a list of numbers to use. If it specifically tells us this, we're using the numbers 1 through 6. All right, so let's go do some examples. So for example 1, if x sub 1 is equal to 4, x sub 2 is equal to 9, x sub 3 is equal to 15, and x sub 4 equals 7. So if we are told that these are our numbers, x sub 1, x sub 2, x sub 3, and x sub 4, we are going to find the summation of x sub I. So what that means is we're going to add x sub 1 plus x sub 2 plus x sub 3 plus x sub 4. We're going to add all of the x terms that we have. So our summation of x sub I, our x sub 1 is 4, x sub 2 is 9, plus x sub 3 is 15, and x sub 4 was 7. So we are going to add those numbers together. 4 plus 9 plus 15 plus 7, and when we add those, we will get 35, and that's the answer you're looking for. So on these problems, you need to make sure you're writing stuff down so you can follow your work here. You need to be able to know and double check that you're doing it correctly. All right, let's look at example 2. So for example 2, I'm going to just give us a data set. And the data set is going to be 10, 12, 14, 16, and 19. Now this data set is basically the same thing what we had here. Here's our x sub 1, x sub 2, x sub 3, x sub 4, and x sub 5. So we can see it in several different ways. So for this data set, we are going to find the summation of x minus 4. So what that means is we are going to subtract 4 from each of our values. So for x minus 4, we will see for each x, we're going to have 10 minus 4 plus 12 minus 4 plus 14 minus 4 plus 16 minus 4 plus 19 minus 4. You want to, again, step out your work because it's easy to make little mistakes and it's easier to find where your errors are. If this is being graded in a way where you're being graded on showing the work, then the more work you show, the more points you will get. So make sure you're stepping out your work there. So 10 minus 4 is 6, 12 minus 4 is 8, 14, forgot a parenthesis, minus 4 will be 10, 16 minus 4 is 12, and 19 minus 4 is 15. When we add those together, we get a total of 51. All right, let's look at another data set. Example 3. So our data set for this is 14, 11, 10, 12, 18, 17, 25, and 23. So here we're just going to find the summation of x. So that means those are all of our x values. We're going to just add them together. So 14 plus 11 plus 10 plus 12 plus 18 plus 17 plus 25 plus 23, and that will give us a total of 130. All right, let's do another part. We're going to use the same data set, but we're going to do another part to it. So let's find the summation of 2x. What that means is we're going to multiply each term by 2. So 2 times 14 plus 2 times 11 plus 2 times 10 plus 2 times 12 plus 2 times 18 plus 2 times 17 plus 2 times 25 plus 2 times 23. Now I'm going to multiply each one. So 2 times 14 is 28. 2 times 11 is 22. 2 times 10 is 20. 2 times 12 is 24. 2 times 18 will get us 36. 2 times 17 is 34. 2 times 25 is 50. And 2 times 23 will get us 46. Now, if we add all of these numbers together, we end up with a total of 260. All right, let's do another data with the same data set. We're going to do another summation. So let's find the summation of x minus 5. So that means we're going to subtract 5 from each number. So first we'll have 14 minus 5. Now notice I'm using the parentheses when I do these, and I did it on the previous problem. We're not really doing anything. It doesn't change any of the math, but it's easier to see than if I don't put parentheses and I just have all these minus 5s. It's harder to follow your math. So I do parenthesize it just to make it like a little grouping, but because we're summing, it's not changing anything. Because we're just adding each term, that just shows me the grouping of what I'm doing. So 11 minus 5 plus 10 minus 5 plus 12 minus 5 plus 18 minus 5 plus 17 minus 5 plus 25 minus 5 plus 23 minus 5. All right, so 14 minus 5 is 9. 11 minus 5 is 6. 10 minus 5 is 5. 12 minus 5 will get us 7. 18 minus 5 is 13. 17 minus 5 is 12. 25 minus 5 is 20. And 23 minus 5 will be 18. When we sum all of these numbers together, we should get a total of 90. All right, we're going to use our same data set, so I'm going to keep it visible here. We're going to use the same data set, and we're going to find another summation. So this time, we are going to find the summation of x plus, whoops, little pen error there. So we're going to find the summation of x plus 100 all over 10, so divided by 10. So the whole thing, we're summing the top part, and then we'll divide the whole thing by 10. So we're going to have 14 plus 100 plus 11 plus 100 plus 10 plus 100 plus 12 plus 100 plus 18 plus 100 plus 17 plus 100, plus 25 plus 100, plus 23 plus 100. And that whole thing, not each individual term, but the whole thing, the whole summation of those is divided by 10. So 14 plus 100 is 114. 11 plus 100 is 111. 10 plus 100 would be 110. 12 plus 100 is 112. 18 plus 100 is 118. Here we're going to get 117, 125, and 123, all divided by 10. Notice it's all one term. They're not separate terms because you're summing the top and dividing by 10 one time. So now we have to sum all of these numbers together. Using our calculator, we will find 930 still divided by 10, and then that will get us 93. And that would be your final answer for that. So be aware and pay attention to this part here. All right, so the next thing we are going to look at is using some eyes. So we're looking at example 4. And for example 4, we are looking at the summation of I is equal to 1 to 6 of 3i minus 2. So what that tells us is we're going to multiply by 3 and then subtract 2 for each term. And our I is equal to 1 all the way up to 6. So it's 1, 2, 3, 4, 5, and 6 are our data set this time. So 3 times 1 minus 2 plus 3 times 2 minus 2 plus 3 times 3 minus 2 plus 3 times 4 minus 2 plus 3 times 5 minus 2 plus 3 times 6 minus 2. And again, I'm doing the grouping so I can see where each term is. So I plugged in 1, 2, 3, 4, 5, and 6 wherever my I was because it's 1 to 6. All right, so now we're going to kind of step this out a little bit, and I'm going to take it step by step because I don't want to lose anybody. So 3 times 1 is 3 minus 2. 3 times 2 is 6 minus 2. 3 times 3 is 9 minus 2. 3 times 4 is 12 minus 2. 3 times 5 is 15 minus 2. And 3 times 6 is 18 minus 2. 3 minus 2 will get us 1. 6 minus 2 is 4. 9 minus 2 is 7. 12 minus 2 is 10. 15 minus 2 is 13. And 18 minus 2 will be 16. And now we add those together, and we end up with 51. And that would be our final answer. All right, let's look at another one. So this will be example 5. And example 5 is the summation of I equal to 2 to 4 of 5i. So here we're going to start with 2, and we'll do 3 and up to 4, and we're multiplying each term by 5. So we'll have 5 times 2 plus 5 times 3 plus 5 times 4. 2, 3, and 4. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. And when we add those together, we will get 45. All right, let's look at our next example. This will be example 6. And on example 6, we are looking at a new data set of 1, 5, 4, 7, 3, and 6. So for this data set, we're going to find the summation of x minus 2 squared. So we're going to plug in each number, subtract 2, and then square. We still have to follow our PEMDAS rules. So we'll have 1 minus 2 squared plus 5 minus 2 squared plus 4 minus 2 squared plus 7 minus 2 squared plus 3 minus 2 squared, 6 minus 2 squared. So 1 minus 2 will get us negative 1 squared. 5 minus 2 is 3 squared. 4 minus 2 is 2 squared. 7 minus 2 is 5 squared. 3 minus 2 is 1 squared. 6 minus 2 is 4 squared. So notice I parenthesize each term when I still have to square it. It's so I don't lose track of negative signs. Remember that when you're squaring this, you're squaring the whole thing. So negative 1 squared, it's the whole thing of negative 1. And squaring something means you're taking something times itself. So that's negative 1 times negative 1, which is positive 1. Anytime you square anything, it will become a positive value. So negative 1 times negative 1 will be 1. 3 times 3 is 9. 2 times 2 is 4. 5 times 5 is 25. 1 times 1 is 1. And 4 times 4 is 16. Because when you're squaring, it's times itself. Now when we add all of these together, we get a total of 56.